Welcome back to All This Math. This is Professor Parker. I got Frantz Fanon here with me. If you're not familiar with Frantz Fanon, Frantz Fanon, Fanon. Do your research. Do your research on Frantz Fanon. Make sure your children know about Frantz Fanon. All right. If you're here, hit the like button. Also, hit the subscribe button if you're not subscribed yet. Excuse me. If you have any questions about anything that I explained, please do not hesitate. Put your questions in the comment section. Or if you got comments, put your comments in the comment section. And also share this video with at least 2 people. Now, what are we doing today? We are going to use number bonds to add 2-digit numbers. This is a skill that might be introduced to your children in the 1st grade, and then they might still be expected to use it in 2nd grade, 3rd grade, and so on and so forth. Now, why does it matter? Why is it helpful? All right, it's different from the math you as a parent probably learned 30, 40 years ago, right? This is going to help your children get prepared for chemistry, doing different types of things in chemistry, right? Dealing with bonds, chemical bonds, and so on and so forth. Also, this prepares us for using the distributive property for doing mental math calculations real quickly with large numbers. All right. And also using distributive property in algebra. It's going to prepare children for that too. All right. Now, how do we create a number bond? So we got 2 numbers here. We got 14 and we got 17. They're being added together. So this is an add-end. This is an add-end. We're looking for the sum. The sum is the answer in an addition problem. All right. So we can either break this number down or break that number down. You have a choice. You can break the first number down. You can break the second number down into 2 numbers where one of the numbers ends in 0. One of the numbers ends in 0. One of the numbers ends in 0. Now, why? Why? You should always ask why when you're learning math. Why are we doing that? Because when you're adding a number that ends in 0, the addition is much easier. For example, if I broke this 14 down into 10 plus 4, because 10 plus 4 is the same thing as 14, it's easier to add 10 plus 17 than it is to add a whole 14 plus 17. That's the purpose. Or if I decided to break the 17 down into 10 plus 7, it's easier to add 10 plus 14 than it is to add a whole 17 plus 14. That's why we do it. Whenever you're learning math and whenever you're trying to explain math to your children, make sure they understand why. Why are we doing this? Why are we doing this? Because that puts them in a space of trying to understand the concept behind it as opposed to just trying to memorize rules, strictly memorize rules. They should memorize the rules. They should end up memorizing the rules, but they should also know the why behind the rules and why the rules make sense. All right. Now, what do I think I want to do? I think I want to, let's break this 14 down. We're going to break the 14 down into 10 plus 4. All right, so I'm gonna create a number bond, draw a line like that, I got my 10, boom, draw a circle around it. Got my 4, boom, draw a circle around that. I got 10 and I got 4. So I'm gonna do 10 plus 17. Now, 17 already has a 10 in it. So I'm putting a 10 with a 10, which makes 20. And then we got 7. So that makes 27. So 10 plus 17 is 27. So now I got my 27, and I still got this 4. Don't forget about that 4. So I'm at 27 plus 4. Now, if your children are adding 2-digit numbers, hopefully by this point, they already have their addition facts memorized from 0 to 20. So they would know that 7 plus 4 is equal to 11. 7 plus 4 is equal to 11. So they could break this down into mentally as 20 plus 7 plus 4, right? And if they know that 7 plus 4 is equal to 11, right, they would be doing 20 plus 11, right? And then you can think of 20 plus 11. I know this seems like a lot, but just stay with me. Stay with me, right? 20 plus 11 is the same thing as 20 plus 10 plus 1, right? So 20 plus 10 plus 1, that's going to be 30. And then the 30 plus the 1 is going to give me 31, right? Another way to do it, if they was at 27 plus 4, right here, imagine we didn't even do all that, right? 27 plus 4, they could use the counting on method from 27 and go up by 4. They could use their fingers, right? So if I'm at 27 and then I put up 4 fingers, but I'm counting by ones, I go 28, 29, 30, 31. How many fingers I got up? That's 4 fingers. This is the number 4. 4 fingers. Where did I end up at? I stopped counting at 31. So that's another way to know that the answer was going to be 31, right? So that was going to be 31. There are a lot of ways to do this. You know what I mean? So we also could have said, like we ended up doing, 7 plus 4 is 11. And then 20 plus 11 is going to be 31 because 11 is the same thing as 10 plus 1. So 20 plus another 10 gives us 30. And then we add the 30 plus the 1 to get 31, right? But again, the purpose of number bonds is to break the numbers down and create easier addition problems, right? When when we're adding tens or groups of 10. All right, so keep that in mind. All right, so now, like I said, make sure you like the video. Make sure you subscribe if you haven't subscribed already. Share this video with at least one other person. Actually, two. Share this video with at least two other people. And if you got any questions, put your questions in the comments. All right, peace.